AP Psychology, the Memory Unit. As you saw in the Learning Unit, learning is a relatively permanent change in behavior or thinking over a period of time, and memory obviously is connected with learning insofar as the persistence of learning over time via storage and retrieval of information. What's a so-called flashbulb memory is the memory of usually an emotionally significant event. This could be a personal one, such as an especially happy birthday party, or it can be something which is communal, such as the people who were around and aware at 9/11 pretty much remember where they were and what they were doing when they heard about the Twin Towers going down on 9/11 2001, and people who were alive at the time, for example, the assassination of John F. Kennedy in 1963, and various other large events, wars, disasters, and so on, usually are recorded in terms of flashbulb memories. And the flashbulb refers to the idea of it being like a photograph, easily recalled with a fair amount of detail. The model you see of information processing on the slide here is a little bit dated, and it is handy in some ways to think of memory as being like a computer, where information is input into a file, it's saved to a disk, and it's read from a disk. But as we discussed in class, a more up-to-date model of memory is one of it being more like a telephone network, where information is constantly crisscrossing and in along various lines, and you sometimes make a call, that is to say you deliberately try to retrieve some information for a test, or you're trying to remember what you went to the store to buy, or sometimes you receive a call without expecting it. A memory will, from sometimes long past, will just come up just as a telephone call, or a text message you're not expecting sometimes comes up on your phone. So a handier, or actually a more accurate way of thinking about memory is not so much as storage of information, but a constant crisscrossing of various forms of data, for want of or bits of data, for want of a better term, among various other networks, and then whatever information we want to use at any given time is extracted from that network, and we apply it to our calculus test, or our psychology assignment, or to our grocery shopping, whatever activity we happen to be doing. Encoding is the processing of information into the memory system, and encoding failure is one of the main reasons we forget things. So something might be logged into short-term memory but never makes it into long-term memory for a number of reasons. We weren't paying close enough attention, or it's just not important enough at the present time. Storage is the retention of encoded information over time. As I said before, just be aware that there really isn't a storage area in the brain for memory information, but it's maybe a handy metaphor to think of that there's actually a storage space for the sake of simplicity for the time being. And retrieval is a process of getting information out of memory. Some psychologists would argue that in fact we never forget anything, that any experience somewhere is in some network inside the brain, and it's just a question of extracting that information, and that's where the problems arise. Alright, so the three aspects of memory. Sensory memory is the immediate initial recording of sensory information in the memory system, and it has large capacity, so we have all kinds of sensory information coming from us at any given time. We have information through our eyes, our ears, our nose, our mouth, our skin, and so on, but only a certain amount of that makes it into working memory or short-term memory. And so very soon after we receive sensory information, some of it is selected for processing. And sensory memory, when it comes to visual information, is really just a fraction of a second. For auditory information through our ears, it may be in the matter of 2 or 3 seconds. But That's the first stop in memory, sensory memory. We have to have senses working, obviously, in order for any information to get inside the brain. Working memory, which is a form of memory we've been focusing on in class because that's the one you need to really develop and discipline for academic success, is the ability to both store and process information at the same time, such as we do when we're doing mental arithmetic. Short-term memory, as we discussed in class, is it's accurate, has a great deal of fidelity to the actual event, so it's clear, but it's relatively small and short duration. So, as we said before, the magic number is 7 items plus or minus 2 and about 30 seconds. And this is why in the initial days of telephone numbers, the numbers were 7 digits long because those developing the phone system knew at that time, on the advice of psychologists, that a number longer than that would be very difficult for people to remember or to keep in mind for 30 seconds and then to write it down for future reference. Now we're in a situation where in a place like Toronto, because we have so many telephones, landlines, and cell phones, we have now several different area codes. But that doesn't change things very much because the area codes are relatively few in number, 416, 647, 905, and so on. And the crucial information to remember, the information that's difficult to remember, is still the 7-digit personal aspect of the phone number. For our purposes, long-term memory, and not all psychologists would agree with this, but we're just going to keep things simple. Long-term memory is anything beyond the 30-second short-term memory limit. And long-term memory can be a matter of remembering anything that you need for the test coming up, and which may well be forgotten by this time next year, up to and including any memory that lasts a lifetime. Typically, a strong emotional memory is going to be the one that lasts longest. And here you can see a simplified memory model on this slide. It might be worthwhile just taking a moment to look at that. There are two kinds of encoding information. There's effortful encoding, the kind of encoding that happens, for example, when a musician is trying to learn a new piece and then has to practice it again and again and again, or if you're trying to master a new concept in psychology, or if you're trying to memorize a Shakespeare sonnet for your English class. Those kinds of things don't happen automatically. Automatic encoding is the kind of thing that might happen, for example, referencing the learning unit, that you learn or you remember along the way of actually pursuing another goal. You might remember the example I gave you in class in the learning unit of latent learning, where you are trying to actually direct yourself to an address of a new friend you've made, and you're going over there to play video games or spend the afternoon together to do this or that. And in finding this person's residence, you also notice as you go along that there's a convenience store in one corner, then a playground in another corner, and various other things. These things are encoded automatically, and you're not actually making any effort to draw them in or work them in to long-term memory. So automatic processing, just following up on what I just said, involves unconscious encoding of incidental information. It has to do with three variables of space, time, and frequency. Over a period of time, for example, when it comes to vocabulary, what was effortful processing, learning complex new words, becomes automatic processing when we have finally mastered the vocabulary, and every time we see that word, we can remember what it is. We don't need to look it up or to remind ourselves of what it is. And automatic processing can be learned, for example, the skill of reading backwards. Not something you're necessarily going to do every day because it's inconvenient, but that can become an automatic process with enough effortful processing. So it's important to remember that automatic and effortful processing aren't necessarily two distinct processes that never impinge on each other. That in fact, effortful processing can become automatic processing. And you can probably imagine a situation later on in life of somebody suffering, an elderly person is suffering from dementia, that what used to be automatic processing, for example, recognizing the face of a loved one, becomes effortful processing. Effortful processing requires attention and conscious effort because normally it is the cognitive demands or the skill demands are something which we are not already familiar with, and it involves rehearsal. Now, this isn't rehearsal in the sense of a musical or dramatic rehearsal, although obviously the idea is related to that. Rehearsal is more the sense of practice and repetition. And as we've discussed in class quite a bit, repetition is crucial for the acquisition of new knowledge and for the acquisition of new skills. There really is no way around it. So studying material once for a test, normally for most of us, isn't going to get the job done. We normally have to study more than once and study in an intelligent and constructive way in order to make sure that our information is going to be there when we need it, that we can encode it for storage so it can be retrieved when the time comes to actually use the information. You might recognize this from one of the activities we did in class, and it refers to a researcher, Ebbinghaus, more than 100 years ago, who was testing the relationship between practice and memory. And so he used nonsense syllables and gave people a series of nonsense syllables to remember on a certain day. And what he found was that the more the person practiced on the first day, these nonsense syllables, the fewer repetitions it took them to learn them on the second day. So practicing new material, as I recommended to you in class, immediately after you've first learned it or discussed it or read it, is a handy and, in the long term, a faster way to remember new material than cramming it in at the last minute before the test. And this has been borne out by a fair amount of research. Distributed practice, that is to say, studying 20 minutes a day over 2 weeks, is a much more effective way of encoding new information or preparing for a test, more to the point for people in your position, than cramming the night before or the morning of the test. We might feel like going into the test after a huge amount of cramming or mass practice that we're ready, but in fact we're not nearly as prepared as we think we are, particularly if we take the time and can discipline ourselves to the kind of continued and repetitive practice distributed over a number of days rather than just the night before. And here you can see some of the results of Ebbinghaus's research. One of the first things we discussed in this unit was the serial position effect. We remember items in a series. We're being asked to remember, say, 10 or 15 words in a series. We remember the first few items fairly effectively, remember the last few items fairly effectively, but the middle tends to get lost. And as we discussed in class, there's a take-home lesson for you in terms of your own study, particularly when it comes to the major multi-unit or midterm tests and, of course, final exams. And that is, it's probably more effective to begin your study in the middle. That is, it's assuming you've already read through and taken some notes on the material the first time around. When it comes time to return to the material, it's probably a better idea to start in the middle and then work your way back to the beginning, and then finally to deal with material that you've learned most recently in whatever course you've been dealing with. This is true mostly of content-orientated subjects like geography, psychology, history, and so on. Not so much true of the cumulative or scaffolded subjects such as math, physics, and some of the other sciences where you're building on a foundation and then working your way up to more complex and more demanding tasks. We've talked about the difference between semantic encoding or semantic memory and episodic memory in class. And semantic encoding or semantic memory has to do with the encoding of meaning. And this includes the meaning of words, but semantic encoding might also have to do with the meaning of personal events. That is to say, we can look back at a romantic breakup as something which has a certain amount of meaning for us, and we understand its significance in our lives. So the idea of semantic encoding isn't just a matter of what we do for school, but it also does impinge on our certain aspects of our personal lives. Acoustic encoding is the encoding of sound, and especially the sound of words, and visual encoding obviously is the encoding of picture images. And here you can see a diagram summarizing these three different kinds of encoding. Now, look at it again and tell me if you, or think to yourself, don't tell me because I'm not there, remember what we discussed about learning styles. Some people like to say that I'm a visual learner, or I'm an auditory learner, or I'm a kinesthetic learner, whatever the case may be. And as we said in class, no matter how we originally encode the information, eventually we have to retrieve it semantically in terms of its meaning. And you can see that this is borne out in this graph based on a study of people who are trying to recognize words after a period of time of not being able to study them. We also can encode through mental pictures, and this can be really helpful when it comes to effortful processing, especially when it's combined with semantic encoding. Let's say, for example, you are trying to repair your bicycle, and you're new at it, and you're not sure exactly how to use the tools and how the various parts of the bike fit together, and you have a diagram laid out in front of you, and that's okay, that's working all right, and you have instructions in a book laid out before you. But imagine how much better it would be to actually go to a YouTube video and see somebody actually conducting the repair that you're proposing to do on your own bicycle. I think you can see quite readily what a difference this would make to your ability to semantically encode the process of repairing your bicycle for next time around by having those very powerful visual images available to you. Mnemonics we didn't get a chance to talk about a lot in class, but your textbook discusses them in quite a bit of detail. These are memory aids, but some people, I've never found them especially useful, but some people find chunking and various other kinds of memory aids useful in trying to remember key information. Acronyms can be handy. I found those handy in the past, but in general, I'm not the kind of person for whom mnemonics have worked very well. But some people swear by them, and your textbook discusses them in a fair amount of detail. And two examples of mnemonics right here. You can see here how chunking helps to create meaning. And if you were trying to memorize, for example, line 3 as opposed to the segments in line 6, it's obvious which one would be easier. And here's a visual summary of the hierarchies that are involved in encoding. When it comes to long-term memory, researchers have found that information tends to be stored in hierarchies. So for example, if we are thinking about in our biology class, we're thinking about the idea of life in general, that is biological, any form of biological life. In general, you might then break it down arbitrarily into animal and plant life. Then the animal life would be broken down into mammals and reptiles and so on down the line. So we're going for from the more general to the more specific term. It doesn't mean that the term hierarchy we tend to think of being, the important things at the top, and that's not necessarily the case. It might, in most cases, it's the general term or the term that encompasses more information that you find at the top of the hierarchy, and then more specific terms as you break down the hierarchy, just as you see laid out here for the process of encoding when it comes to memory. So, putting the information in to memory isn't the problem for most people. The problem is getting it back out when we want it. And we are often, shortly after an experience, left with a visual image of what we just seen, which is called an iconic memory, or an echoic memory, which is part of the auditory system. But beyond that, we may not really be able to account for when or where or how we're going to get the information out again. And the problem comes with the conversion of information in short-term memory, as we've discussed in class, about 30 seconds long, 7 items plus or minus 2, and long-term memory. And you can see on this graph here what happens to information in short-term memory as a matter of seconds passes. By the time in this particular task where people were asked to remember consonants, a list of consonants, by the time you got to 18 seconds, you're down to fewer than 8% of people actually able to remember the list of consonants that were given to them to memorize. So, short-term and long-term memory obviously interact with one another, and memory, long-term memory especially, is sort of one of the holy grails of memory research. Everybody wants to know how it works, and nobody's really been able to figure it out yet. But or completely figure it out. But at the biological level, there is one thing that neuroscientists are more and more honing in on, and this is the idea of long-term potentiation. And long-term potentiation happens in the hippocampus, in the temporal lobe of your brain. And when we are repeating information again and again and again, we're studying our calculus or our psychology, or we're at cheerleading practice, practicing a particular formation, whatever it might be, our brain is very good at deciding that something's important. And at that point in the hippocampus, it will actually make changes that will create bigger synapses. It'll create more points of contact among neurons, because if I'm repeating this information, it must be important. It must be something I'm going to need in the future. And neuroscientists refer to this as LTP, or long-term potentiation. I won't go into the details of the actual molecular biology of the process. That's discussed in your textbook. But this is something that is actually measurable in terms of memory. The psychologists, neuroscientists, neurobiologists can actually observe this happening. So it's a crucial development, and it's really within only the last 20 or 30 years that long-term potentiation has come to be understood. Maybe like ancient history for you, but not for me. Amnesia is the loss of memory, and amnesia tends to be loss of memory for for personal events. For it's episodic memory, forgetting who you are, who your family members are, and so on. Facts and figures may well be remembered. Stuff that a person studied in high school years and years ago may be remembered, but amnesia tends to take away the aspects of one's own experience. Explicit memory is memory of facts and experiences that we can consciously know and declare. It's also known as declarative memory. And as I said, referencing the previous slide, this is something in which the hippocampus gets into the act in a very important way. And implicit memory, sometimes called procedural memory, has to do with skills and emotion. So, what's the difference between explicit memory and implicit memory in practical terms? Well, think of the process of tying your shoe. Just think for a moment how difficult it would be to give verbal instructions to, or how difficult it would be every day of your life if you had to use verbal instructions. Use your explicit memory, word for word, to describe how to tie your shoe. This is something that's stored in implicit memory. It's a skill. You know how to do it. You don't really have to think about it. In fact, you can be tying your shoe and you can be talking to somebody about the big chemistry test coming up. So, if you want, that may be a good way to think about explicit memory if you need to remember for the sake of tests that the difference between explicit memory and implicit memory. Explicit memory has to do with knowledge which can be retrieved and spoken in some way, and implicit memory has to do with knowledge which is probably either emotional or which is skill and physical activity based. And you can see a handy diagram here of the subsystems of long-term memory. And you can see here a little picture of the hippocampus, called the hippocampus because it's a Greek word, and it's a Greek word for seahorse. So the original brain anatomists looked at this piece of anatomy and said, that looks like a seahorse, called the hippocampus. Crucial in the storage of long-term memory. Alright, so when we need to use the information, there are two processes, recall and recognition. Now in everyday language we tend to use these terms interchangeably, but they're not the same thing when it comes to psychology. Recall is a measure of memory in which the person must retrieve information learned earlier. So the cue tends to be very general, and we're not choosing from a list of options. For example, an essay test will test recall of certain memory. It'll give you a general question, and then you have to decide on the information that you need to answer the question, and then you have to run an inventory of long-term memory to look for the information that you need. Same may be true of a fill-in-the-blank test. Recognition is a kind of memory used for the multiple choice test. And so you have a question and then a list of 4 or 5 options, one of which must be true, and so you connect the question, the stem, with the correct option from the multiple choice options, and then you hope that you get the question correct and earn your mark. This is the kind of thing that happens on a multiple choice test, as I said before. And recognition connects 2 different cues, which are right there in front of you, whereas recall gives you 1 cue, and then you have to go through your inventory of long-term memory to find the information that you need in order to deal with whatever task you've been assigned. Relearning information happens much more quickly than learning the first time. This is why when, for example, people are in semester schools, will do math for a semester and then they'll take a semester off and they go back to math the following semester. They have to relearn some stuff which they learned maybe as long as a year ago, but it comes back much more quickly because they've already been through it once. Priming happens when there's activation, and sometimes unconsciously, of particular associations in memory. So you might be primed, for example, to remember certain information simply by being in an environment in which you learn the information the first time. The environment primes your memory of information which you originally got while in that exact same environment. It is much easier to remember information if we're being asked to remember it in the environment in which we learned it. So you can see here on this graph that if we are asked to memorize certain items, when we are in one context, and then for example, water or land, we might be in scuba gear underwater, being fed lists of words to learn through a headphone device, then asked to remember them on land, we're not very effective at it. However, if we go back into the water and ask to remember them, then we are more likely to be more accurate. And the reverse is true. The information that we learn on land is much better remembered when we are asked to remember it on land than when we would be in water, as you can see laid out in the graph here. So the take-home lesson from this, put simply, is context is very important when it comes to retrieving information in memory. That's why it's helpful to do your tests in your exams where possible, in rooms where you originally learned the information, because the cues, that is the external environment, which is around you, affecting your senses, is going to help you retrieve the information when you need it. And you can see detailed in this slide some examples of retrieval cues. Mood congruent memory and state dependent memory are two which you want to pay especially close attention to. And you can see the results of a study regarding retrieval in infants on this slide. What do we mean by forgetting? Well, for a psychologist, forgetting is encoding failure. What that means is information never makes it from short-term memory to long-term memory. Sometimes because we're not paying close enough attention, other times because the information just isn't important enough to us. So think of how often you've handled, for example, a loonie in your life, thousands of times, I would guess. And take a moment if you want to try this right now. Take a pencil and paper and try to draw what the face of the loonie looks like. Whose face is on the front of the loonie? In which direction is the face pointing? What words are printed out on the loonie, and so on. As you can see here, for the case of the 1-cent piece in the United States. We handle these things possibly every day of our lives, and yet when we're asked to retrieve the details of them, we can't. Why is that? Because the details of what they look like are not important. What's important is what we use it for, the value of the item, the loonie, the penny, the $10 bill, whatever it might be. Here you see another graph connected to Ebbinghouse's research. And when it comes to remembering items in a list, once again, as we've been doing in class again and again and again, you can see that forgetting happens very, very quickly in the first few days after dealing with the information if we haven't practiced it, but then the forgetting tends to level off over time. And another example for Spanish learned in school. And this had to do with the retention of certain vocabulary. So, is forgetting encoding failure or retrieval failure? Well, as you can probably figure out, it can be both. If it doesn't get in first time around, although some psychologists believe that it's always there, once it's in short-term memory, it's going to be in long-term memory in the neural circuits in our brain somewhere. It's just a question of getting at it. There's some debate about that. However, obviously there's certain things that just aren't important enough to us and we don't pay attention to them, and they don't get into long-term memory, and therefore we can't use them when we need them. Some things get in there and then we need them a year or two or even longer later on, and we can't get at them. So both encoding failure and retrieval failure contribute to what we commonly call forgetting. There can also be interference in this process. There are two kinds of interference: proactive interference and retroactive interference. Proactive interference is forward acting. So let's say I've learned French and I want to learn Spanish. So I might, in learning my Spanish, start to pronounce my French in a Spanish accent, or in fact I might start conjugating my verbs in Spanish with French conjugations. What that means is that my priorly learned French is interfering, is having an effect on my learning of Spanish. And retroactive interference is just the other way around. My new Spanish learning eventually may interfere with my old French learning. And in fact, in learning Spanish, when I try to conjugate my French verbs, I might start making Spanish mistakes in my French conjugations. See if you can think of examples of this in your own experience. And here's a diagram of what I was just talking about. Not really a diagram, a graphic. This is a diagram having to do with retroactive interference. So forgetting can happen at any memory stage. It can, from short-term memory through the conversion of short-term memory to long-term memory, and in long-term memory itself. As we process information, we filter, alter, or we lose much of the information. And biologically, as we said before, your brain is very good at deciding what's important at any given time. And if it turns out that you haven't used information in a long time, but you're doing something new, your brain will make a decision and start to reduce the contacts among neurons for that old information because it's not being used, and use that space for contacts among neurons for new information. It only makes sense. Your brain is adjusting to its environment and working with you, in a manner of speaking, to help you achieve what you need to achieve. Motivated forgetting is people deliberately either repressing memories, well, not, sorry, that's the next thing. People deliberately trying to um, erase memories from their mind, or unknowingly or unconsciously revising memories, usually as a result of a traumatic event, or because the memory is so threatening to their sense of themselves that they can't deal with it. Repression is a Freudian term, and as we'll see in a couple of weeks' time, Freud believed in a number of defense mechanisms that we have in order to maintain our ego integrity. And he saw repression as a defense mechanism that banishes from consciousness anxiety arousing thoughts, feelings, and memories. So this isn't a conscious process on our part, it's an unconscious process, as far as Freud is concerned, to help us deal with things which we find emotionally intolerable. Memory, as we saw right at the beginning of this unit, or very close to it, we know that memory isn't like a tape recorder, and it's not like a video camera, and it doesn't remember every little detail, and it doesn't necessarily remember anything accurately. And when I gave you that list of words having to do with nighttime and sleep at the beginning of the unit, and many of you swore I used the word sleep in that list, where in fact I hadn't used the word sleep at all. You can see an example there of exactly how memory is constructive. So it's a process of putting things together in a way that may or may not be accurate. There's a lot of filling in of missing pieces when it comes to memory. So there's a misinformation effect that's incorporating misleading information into one's memory of an event. And there's source amnesia. That's when we attribute to the wrong source an event that we experienced, heard about, read about, or we imagine. We might have imagined, as a simple example, that one person told us some piece of gossip about the big new romance that's broken out somewhere in the school, where in fact it was a completely different person who told us about it. Fancy words once again for two things which are fairly simple and straightforward. You can see though that this could lead to some trouble, particularly when it comes to serious issues like crimes and accidents and so on. Depending on how questions are framed to eyewitnesses of events, and eyewitness testimony, I think most lawyers will tell you, is very often very suspect. If the question is framed, for example, regarding a car accident, and it uses the word smashed as opposed to ran into each other, then a person is more likely to remember the accident as being more serious and more destructive than it actually was, as you can see from these two pictures here. However, if we're simply asked how fast were the cars moving when there was the accident, then that will also change the way our brain rather, pardon me, constructs our memory of the event. So once again, key things: it's not a camera. It's it is a process. Your memory is a device that takes elements of experience and constructs itself in a way which may or may not bear on the reality of the event as it occurred. A controversial issue in psychology, which we're not going to talk about very much, has to do with repressed memories and the idea of drawing out repressed memories of people who may have suffered from childhood sexual abuse. There is no strong evidence that this can be done. We know, unfortunately, that child sexual abuse does occur. We know that adults do forget these episodes, but we also know that there is no proven technique for helping people to recover these memories of these events. And in fact, people's lives and careers have been ruined by unscrupulous psychotherapists who have encouraged patients to, or have led patients to believe that through hypnosis or some other technique they can remember a traumatic event from the past, for example, a case of sexual abuse. The patient remembers, in quotation marks, the event and accuses a certain individual of having perpetrated the event when the individual didn't do that at all. And charges are laid, and it only comes out years later that, in fact, no abuse of any kind happened, that this was completely a construction of memory and not an event that happened in reality. And you can see how dangerous this can be to the lives and livelihood and well-being of perfectly innocent people. False memory syndrome is somewhat related to this, as you can see. And these are the things that most people agree on regarding memory construction. The reason memories of things happening before age 3 are unreliable is a couple of reasons. One, our ability with language isn't strong enough before age 3, so we haven't really developed semantic memory at that time. And two, the networks of neurons, if you can imagine your brain being like a large net or a piece of knitting, which over time eventually becomes tighter and tighter and tighter, the networks of neurons aren't dense and thick enough for memories to take hold and to be drawn out, at least in explicit memory, before the age of 3. This look familiar? Look at it again. Some of the stuff I've been recommending to you in class. More advice on the same lines. And I'm out.